okay, doom volume, and that is segmental. Okay, if we have a doom, let's say something like this. Now, segmental means something like this guy. It is segmental now. So it means we have to determine the volume of this thing. And this should be actually, you can say the volume must be something like pi, and there is actually h square by 3, and then you have to multiply that with 3r, and then subtract h again. R is actually radius of the same doom, okay? This can be like this thing, okay? And the radius is actually from the center to the circumference, maybe like this. So this is the radius. Now h is actually the height of the same doom. Let me change the color to red. And this is actually from this center till the top, which is the rise of the, you can say, doom. And this is h. You can say the rise. And this is simple. And pi is pi. Okay, so you have to put only these two parameters in order to have the volume of a segmental doom. Is it clear?
Yes, sir.
So this was actually for the solid segmental, okay? Now, if we have a hollow, because dooms cannot be you can say solid, because that can be a heavy structure then. And supporting that can be like maybe something like impossible, okay? So always dooms are, you can say, constructed, okay, are modeled, you can say hollow, like this. So we will have an example so we can understand the problem, okay? So this is segmental doom, because the curvature may go like this, and it is something whose center is just, you can say, above the center of the ball, or maybe sphere, like this. Okay, so this is now segmental. It means we should have different parameters now. Let's say we have the center over here, and the radius, which is known, actually, let's say that is, maybe I'm gonna take the internal one. Okay, let's say this one. And let's say that is 9.5. And now let's say the height, which is actually internal, this one, 4.5. My handwriting is very good, but because of the touch pen, it is a little bit complicated, okay, to handle these things. Never challenge it. All right, so we have these informations, and we are asked to determine the volume of the same doom. Okay, this is not arch, okay? It is doom. Let's just calculate it. So the volume of the doom can be now, if you remember, for a solid, it was actually pi h square by 3, and then it was 3r minus h. But this time, as you can see, it is segmental as well as it is hollow. This formula is for segmental, but it was just solid, you can say. So ये क्या बन गया भाई? ये बन गया h2, which is of course 4.5 feet, and this one, that is actually h1, which is 5 feet. And here we have another radius, which is r1, and that is going to be 10 feet, because the thickness, okay, this thickness T is 6 inches. Okay, the slab, it means 6 inches slab. The volume can be actually pi h square divided by 3, and then 3r minus h. Okay, so this is for a solid, and I'm gonna say, let's say, I'm gonna subtract the internal one from the external. So let's say this is h1, this is r1, this is h1. What do you say? We will just subtract the internal, okay, just in this form. Pi, I'm gonna say h2 square, right, and then divide by 3, and then 3 times, that is r1, but this time we can have r2 and minus h2. Is it clear? Okay, so after putting all these information in the same formula, okay, over here, you should get 147, okay, it's 45 maybe, 145.56 CFT. Okay, you have to try this and then give me the answer in, you can say, WhatsApp group. Okay, if you have this answer, it means you are correct. If you don't get this answer, it means you are wrong. You are doing something wrong.